Hi everyone. We are doing permutation and combination lesson 6. This is combination part 2. Combinations are collection of objects when the order doesn't matter. When the order is not irrelevant in the questions, you can shuffle them around. The order is not matter in the question, then you use combination. You use the C button in your calculator. Now let's try example number 1. So this is similar to last lesson, except the question will now have the word at least and at most, which means you just similar thinking. You just need to do a few more work. Okay, let's see. A student council want to form a committee or committee. Question will be combination question. There are 11 students in which 5 male, 6 female. Okay, how many ways can the 5 member? So out of 11 students, you want to pick 5. So if there's no restriction, it's just simply 11 students, you choosing 5. The order doesn't matter. Student A, B, C, D is same as student C, D, E, A, B. It's the same group of people. So they are in the subcommittee. So that's the member. The order doesn't matter. So it's C. Okay. Exactly 3 males. Okay, if what it didn't say is if there's 3 females, which means there are 2 males, right? Imply there are 2 males for the 5-member subcommittee. So where does the 3 females come from? Come from the 6. 6 female, you choose 3. 5 male, you choose 2. So here those are the 11 people. Here are the 5 committee. Is 3 male and, right? So you multiply them. Okay, put it in the calculator, you get the answer. I won't write down the answer here. Now, the new type of question that we will see here in this lesson is at least or at most. At least 3 female. What does that mean? At least 3 females. So you want to have at least 3, but it could be what? It could be 4 females and it could be 5 females. So whenever you have at least whatever or at most, it just means you have different cases. You have this case or this case or this case. Notice I say or. You add the cases together. So here we go. You could have 3 female and 2 male, right? Or at least 3. So you can have 4 female, which implies there's 1 male. Or you can have the entire committee composed of female. So 5 female. Whenever you say or, you add them. You add the answer. For each one, we know the answer. This is part B, right? 6 female, you choose 3. 5 male, you choose 2. Well, the other one are similar. 6 female, you choose 4. Multiply. 5 male, you choose 1. Here, 6 female, you choose 5. That's it. That's the answer. Add them together. That's the lesson, right? Just telling you, or like this lesson is just about at least, at most, then you have different cases. You write the cases and then you add them because any subcommittee could be this case or the other case or the other case. You just calculate each one and then you add them. All right, so let's just see more example. All right, 52 cards. Playing cards is also combination question. We have an example last lesson. We'll have an example here. 5 card hands. No restriction. 52 cards. You just pick any 5. Here we go. That's the answer. At least 4 reds. Okay, if you have 5 cards, at least 4 reds, which mean what? What are the cases? Lay it out. Which mean you have 4 red. Well, but you have 5 cards. So what happened to the last card? 4 red, 1 black. You can have all 5 red, isn't it? Right? Then it's at least 4 red. So therefore, these are the 2 cases. You add them. So how many red are there? There are half of the deck are red. So 26 are red. And you multiply, and one of them are black. Right? You have to do them separately. You can't combine the black and red together. They have to be separate. 26 red, 26 black, and then you do them separately. Here, 26 red, you choose 5. Add them together is your answer. You need to put the answer in it. You need to put this in your calculator to get the actual answer. But here I'm just writing you going through the thinking process. Next one. At most, you can only have at most 2 kings. You cannot have more than 2 kings. So what are the cases? All right. Oh, at most 2 kings. So sure, you have 2 kings. And 3 other will be non-king, right? Non-king. you can have 1K and then 4 others, right? 4 other non kings, all right? And sometimes people will stop here, all right? At most 2 kings, so 2 kings and 1 king. Hey, you're missing one case. What case did you miss? At most 2 kings, so you can have 2 kings, you can have 1 king, you can have no king at all, no king, right? So don't miss this case. Now let's do the math. How many kings are there in the deck of cards? There are 4 kings. You choose 2 of them. Then how many non-kings are there? There are 48 non-kings. 52 cards, right? Take away 4 kings. 52 minus 4. There are 48 other cards. They are non-king. So you just choose 3 of them. And then here, 1 king. So 4 king, you choose 1. 48 non-king, you choose 4. Finally, 48 non-kings, you choose all 5. Make sure every combination you have 5 cards because you're doing a 5-card hands, right? Make sure the number on the right indicate what you pick, right? What you choose should add up to 5. So that will be the answer. All right. So now let's try using complement. What does it mean, complement? Remember you learned it in Unit 1. Complement means the opposite, right? The other set. If you think about set theory, if your set contains all the odd numbers, the complement of that will be all the rest, all the even numbers. All right? So complement. Here it says you can use complement to think about at least and at most question. So let's try. All right? Consider example 1. There are 462 ways in which 5 members of the subcommittee can be chosen. Students were asked to determine how many 462 possible subcommittee contain at least 1 female. Now, if you do it in the positive way, at least 1 female, mean what? It means 1 female, 2 female, 3 female, 4 female, 5 females, right? Wow. So these are the cases here. 1 female. Oh, they make a typo here. It should be 1 female, 4 male. 1 female, 2 female, 3 females, 4 females, and 5 females. You're adding 5 cases together. Same logic, nothing wrong with that. If you have patience, if you have time, you'll get the answer. But there is an easier way. All right, what's the easier way? The easier way is to think the opposite. Right? To think the opposite. This is the opposite. Well, a subcommittee can only have 1 female, 2 female, 3 female, 4 female, 5 female, or no female, right? So if you have no female, 1 female, 2, 3, 4, 5 is all the possible cases. Well, all the possible cases is this, 462. All the possible cases is 11 people choose 5. That's all the possible cases, including no female, 1 female, 2 female, 3 female, 4 female, 5 female. So in order to get 1, 2, 3, 4, 5 female, separately, how about you just find all cases and you take away the cases that's not in here. Take away the complement. Take away the cases when there's no female. So this is what the thinking is. The total number of subcommittee, no restriction, which is 11, okay, which is here, 11C5. You take away the number of ways have no female. All right, so there are 6 females. So no female, which means all of them are 5 females. So take away 5 male, 5. All right. So anyway, so that will be the answer. The outcome, no female, is the complement of at least 1 female. In general, number of ways for the required outcome is the total ways, no restriction, minus the number of ways for the complement. Why do you need the complement? When the complement is smaller than your actual question, you use complement. All right, so let's try the following question. Consider a deck of 52 cards. How many different 5-hand cards can be formed containing at least 1 club? At least 1 club is 1 club, 2 club, 3 club, 4 club. Well, you can do it that way. 4 cases, you get the answer. Well, how about think the opposite? At least 1 club means no club. Okay, no club. How many ways to choose no club? Well, no club means there are 13 clubs in a deck of cards. No clubs mean you choose remaining 39. Okay? 13 club in a deck, 52 minus 13 is 39. 39 other things, heart, spade, and diamond. All of those cards, you choose 5. So these are all the these are all the ways that have no club. Well, the question is not about no club. The question is about at least one club. So how about take all the ways, okay, which is 52C5. That's all the possible ways, including clubs and no clubs. You take away all the no clubs, then you get the one that has at least one club. Does it make sense? Right? That's a quicker way to get the answer. Okay, so make sure you understand this. Okay, so today's lesson is about at most, at least. It just means the same thing with a couple cases you need to consider. But there's a shortcut here. You can think complement. For this question, if they say at least 3 clubs, I won't use the complement method. Because if it says at least 3 clubs, I will have 3 clubs, 4 clubs, 5 clubs. I just need to add 3 cases together. Why use complement? Because the complements will be no club, 1 club, 2 clubs. It's all the 3 cases. So it's equal. And also, if you do the complement, you need to do the all way minus all the 3 cases, which give you 4 number to crunch in. So it's even more than not using complement. So if it says at least 3 clubs, I'll just do it directly. Find out 3 clubs, 4 clubs, 5 clubs. But if it says at least 1 club, instead of doing 1, 2, 3, 4, 5, which is 5 cases, I just do whole thing minus 1 case, which make it easier. Okay? So now combination which are equivalent. So they just want you to see the following. You realize 10C2 equal to 10C8. So they give an example here. Here, you have 10 toy cars. They want you to select 2 cars. Okay, let's say I select this 2, right? Another question is, you have 10 toy cars, you select A. You find out they are exactly the same. How come? Because by selecting this A at the same time, you're selecting, by selecting this 2, you are saying you are selecting the other 8 that you're not chosen. So selecting 2 and selecting 8 are the same. So 10 choosing 2 is same as 10 choosing 8. So they just want you to show why, because using the factorial notation, 10C is 10 factorial, all right, over 10 minus 2 factorial, over 2 factorial. And then 10C8, using the formula sheet, is 10 factorial, is n factorial over n minus r factorial, which is 2, over r factorial. Oh, of course they are the same. Now you realize. So give another example. Give a general rule. So the general rule is the following. All right? NCR is same as NCN minus R. If you have 100C5 is same as 100C n minus R. 100 minus 5, 95. By choosing 5 objects from 100 is same as choosing the remaining 95 objects you didn't choose in the 100 object. It's the same. Okay, so this is what this exercise wants to tell you. So there are more example, or there's one more example. All right, it will be similar. Let's try all player for the last practice. They shook hand. Okay. Yeah, I will skip this question for now. All right, just work with the combination question that you have. So for the homework, don't do 6 to 9. Just do 1 to 8, 1 to 5 for now. Applying what we have learned today. All right, either use cases, add them directly, or use complement. Take the all possible way minus the complement cases, then you get the answer. All right, good luck.